Alternating current fundamentals. Number 3, measuring AC.
In the last video, you saw how the close link between electricity and magnetism forms the basis of operation for two common electrical devices.
You saw that when a conductor cuts a magnetic field in two different directions, voltages of two different polarities are induced. A simple generator was examined. You saw how it produces alternating current by using the principles of electromagnetic induction. The process describing how an electric motor develops its rotational power through electromagnetism was also presented.
In this video, an AC signal will be examined.
You'll see how alternating current can be measured, and sine wave terminology will be presented.
Now that you have some understanding of how AC is generated, let's see how it can be represented graphically. To understand alternating current, it's helpful to visualize voltage or current changes over a period of time. This can be done using waveforms.
Waveforms are graphic representations that show the magnitude and the direction of voltage or current at every instant of time. Let's see how a waveform is constructed. Let's use graph paper. Start by drawing two lines that meet at a right angle. The upright line or vertical axis is used to chart a range of voltage or current values. Positive values occur above the juncture, and negative values occur below. The polarity of a given signal will be determined using the vertical axis. The horizontal axis, on the other hand, can be used to keep track of the passage of time.
You'll see how this axis can also be used to indicate degrees of rotation, as in the case of an armature revolving in a generator. To help you understand how AC is produced and the waveform developed, a drawing that represents the voltage from a simple AC generator will be used.
The coil will be rotated clockwise between the magnetic north and south poles of the electromagnet. You've already seen in the previous video how the voltage output is zero when the coil is not cutting any magnetic lines of force. This is plotted as zero voltage at the 0 degree point on the horizontal axis. This axis will be referred to as the baseline. As the coil makes 1/4 of a revolution, the voltage increases from 0 to a maximum or peak value in one direction. The point at which the voltage reaches its peak on the vertical axis occurs at 90 degrees on the horizontal axis. As the coil continues to turn and completes 1/2 of a revolution, the voltage decreases until it reaches 0 again. At this instant, the coil is not cutting any magnetic lines of force and has completed 180 degrees of rotation. The coil continues to rotate, causing the voltage to reverse polarity.
Remember, this change of polarity occurs because the conductor is cutting the magnetic field in the opposite direction.
At 3/4 of a revolution, the maximum negative value is reached. This occurs at 270 degrees on the horizontal axis. From this point, the voltage gradually decreases to 0 as the coil completes its rotation. At this point, the coil has completed 360 degrees of rotation, or 1 full revolution. Notice the shape that has resulted. This waveform is sinusoidal and is known as a sine wave. Keep in mind that current would also form a sine wave because Ohm's law, E equals I times R, is equally as valid for AC as it is for DC. That is, assuming a constant resistance, any changes in current, I, will be directly proportional to changes in voltage, E. Therefore, the current waveform for AC takes on the same visual appearance as a voltage waveform, that of a sine wave.
Let's consider some important sine wave terminology. As a technician, you will need to know these terms.
First, let's look at a cycle. As an example, here are two cycles of an AC waveform. The area between any point on the sine wave and the next point at which the waveform begins to repeat itself makes up one cycle. The distance between the two positive peaks represents one cycle. Notice that this is exactly the distance between the two negative peaks, which also represents one cycle. The distance between any two positive or negative peaks of the wave is exactly the same as the distance from the first zero value to the third zero value, where again the waveform begins to repeat itself. Another way to think of a cycle is as a complete set of positive and negative values.
Stop the program and complete activity number 1. When finished, continue watching the program.